So, hello guys, let's continue. Question number 4. State the principle of superposition of waves. What is the principle of superposition of waves? The principle states that when two or more waves passes through the same region or space at the same time, the actual displacement at any point, at any time, is the vector sum of the separate displacement. So that is what the principle of superposition states. The next question says, briefly describe Huygens principle. How do you describe Huygens principle? Huygens principle deals with wavefront and wavelets. This is a diagram for the Huygens principle. A, B, C, and D. A, B, C, and D are called the wavefront. So each wavefront is the envelope of the wavelet, and each point on the wavefront acts as an independent source to generate wavelets for the next wavefront. So that is just a brief explanation of the Huygens principle. Let's come to question number B. The voltage from an electromagnetic wave traveling on a transmission line is given as, we have V of xt equals to 10 e raised to the power minus alpha sine 4 pi times 10 raised to the power 9t minus 30 pi x. So V, we are told to find the frequency. So how do you calculate frequency? W equals to 2 pi f. So make f the subject of formula equals to W over 2 pi. And from your equation of wave, this is y of xt equals to a sine 2 pi t minus kx. So from that, our W is equal to what? The whole of this 4 pi times 10 raised to the power 9 over 2 pi. So 2 cancel to 2 here 1, 2 here 2. So f equals to 2 times 10 raised to the power 9 hertz, or 2 gigahertz. Giga is 10 raised to the power 9. So what the next thing we have to do, we have to find the wavelength. Wavelength k is equal to 2 pi over lambda. So our lambda is 2 pi over k. Our 2 pi is there. K is 30 pi. So cancel this. 2 in 30, that's 1 over 15. If you divide 1 over 15, you should be having 0.067 meter. As what's the next thing? Velocity. How do you look for velocity? V equals to f lambda. What's our f? 2 gigahertz. What's our lambda? 0.067 meter. So if we multiply that very well, we have 133.6. What's our unit? Meter per second. So 133. V should be 133.3 times 10 raised to the power 6 meter per second. Not 133.6. 133.3 times 10 raised to the power 6 meter per second squared. So hello guys. So let's go to our OOT, which is electricity and magnetism. The first question, define electromagnetic wave. So how do we define electromagnetic wave? That is EMF of a cell is the potential difference between the terminals of the cell. That is, when it is in an open circuit, when it is not delivering any current to an external circuit. That is what we call EMF. So question B, a cell of EMF and internal resistance R was connected in series with two series external resistor 8 ohm and 2 ohm. They now make us to understand that a high resistance of voltmeter connected across A was found to read 8 volts, when another resistor C of 8 ohms was connected parallel to A, and then across A and C, the voltmeter reads 6 volts. So they say we should draw the circuit diagram of the two arrangements. This is the circuit diagram of the first arrangement, which is two of them connected in series. Look at it with your 8 volts. This is the second diagram, A, B, and C, connected in series and also in parallel. So they want us to calculate the internal resistance of the cell, that is your small r. Remember your formula, I equals to E over R plus R. You can cross multiply. P is equals to I in bracket R plus R. So if you use your formula, but we know Ohm's law, I is equals to V over R. What's our V? Our voltage is 8. What's our R? A is 8. 8 divided by 8 gives you 1. So coming back to the formula, E is equal to I into R plus R. Your I is already 1. Your R is the two resistors connected in series. 8 plus 2, that gives us 10 plus R. So 1 times 10, 10 plus R. So that's why I tag it as equation 1. From the second circuit involving A, B, and C, the effective resistance of A and C is 4. How is it 4? These are connected in parallel. So if you want to calculate, that's 1 over 8 plus 1 over 8. That gives you 2 over 8. Then 1 over the effective resistance. 2 here over 2 here, so that's 1 over 4. If you cross multiply, we get 4 ohms. Now from VAC, the voltage across A and C is 6 volts. Then go back to your Ohm's law. I is equal to V over R. V is 6. Your R is now 4. 2 in 4, 2. 2 in 6, 3. 3 over 2 gives us 1.5 ampere. That's the unit for current. Then we have calculated our E1, which is this. Then we want to calculate our E2. I is 1.5. R is now 6 from our question. R is now 6 from our question plus R. So 1.5 times 6 gives you 9 plus 1.5 R. So bring E1 equals to E2. 10 plus R plus 9 plus 1.5 R. So bring your 9 outside. 10 minus 9 give you 1. 1.5 R minus R give you 0.5. So make R the subject of the formula. You have R is equal to 1 over 0.5, which is 2 ohms. So substituting R in equation 1. Equation 1 is always telling us that 10 plus R is equal to 10 plus R. So 10 plus R, 2. R is 2. 10 plus 2, that is 12 volts. So that is the EMF, electromotive force of the cell. The next question says electrostatic induction. Explain electrostatic induction and mention one method of producing electric charges. When you talk about electrostatic induction, it's just the process of charging an electrically neutral body by bringing it near a charged body. So if you bring an electrically neutral body, you bring it near a charged body, it produces what we call electrostatic induction, force of attraction between them. So how do we produce electrostatic charges? 1 by induction, 2 by friction, and 3 by contact. That is when you come close to each other. So those are the method of producing electrostatic charges. So hello students, we come to the last part of 003, electricity and magnetism. And question 16 says, what is electrostatics? Electrostatic just means electric charges at rest. Or we can say electrostatics is the branch of science that deals with electrical phenomena that arises from stationary electric charges. So that is just electrostatics. Explain how you can charge a gold leaf electroscope positively by using the method of charging by induction. You know, there are different methods of charging electrostatic induction, which is induction, friction, and contact. They say how you can charge it by induction. So the method you are being asked is very, very important. Look at how we do that. If a negatively charged rod is brought close to the disc, the positive charge in the neutral electroscope is attached to the metal disc, and negative electrons are left behind. But if the metal disc is empty, that is, if it is placed in the earth before the charged object is removed, most of the electrons in the metal plate and the gold leaf are transferred to the earth, and hence the leaf begins to collapse. The gold leaf, it begins to collapse. But when the charged rod is removed, the positive charge is spread around, leaving the plate and leaf with the same charge. So then the C part, two charges are located on the positive x-axis of a coordinate system. Q1 is this 2 times 10 to the power minus 9, which is 2 cm from the origin, and Q2 is 3 times 10 to the power minus 9, 4 cm from the origin. You see, what is the magnitude of the force exerted by the two charges on a charge Q3? 5 times 10 to the power minus 9 located at the origin. Now remember your Coulomb's law, which says F is equal to KQ1 Q2 over R squared. That is the product of two charges is directly proportional to the product of two charges is inversely proportional to the distance separating them. That is, charges Q1 and Q2 are directly proportional to each other and inversely proportional to the square of the distance separating them. So, but K is a constant, which is 1 over 4 pi epsilon naught. Epsilon naught is your permittivity of free space, which is 8.85. Look at it here. Epsilon naught 8.85 times 10 raised to the power minus 12 Newton meter square per Coulomb square. So if you use that value, where we say K is 1 over 4 pi epsilon naught, 1 over 4 pi times 8.85 times 10 raised to the power minus 12. If you put all this together, you have 9 times 10 raised to the power 9 Newton meter square per Coulomb square. So you get that value. Use your calculator, you get it. So R1 is 0.02. R1 is 2 centimeter here, so I converted to meter to give me 0.02. That is 2 over 100, that's 0.02. Then 4 over 100, which is 0.04 meter. So F31, K, Q3, Q1 over R31 square. K is 9 times 10 to the power 9. Q3 is 5 times 10 to the power minus 9 from our question. Q1 is 2 times 10 to the power minus 9 from our question over R31, which is 0.02 square. If you multiply all that and divide, you get minus 2.25 times 10 to the power minus 4. Is a vector, so you put your I, then your unit of force, Newton. Then the next one, F32, KQ3, Q2 over R32 square. K is your 9 times 10 to the power 9. Q3 is 5 times 10 to the power minus 9. Q2 is 3 times 10 to the power minus 9 over 0.04 square. If you divide that value, you get minus 8.44 times 10 to the power minus 5 I Newton. That is the vector notation. So if we want to find the magnitude of the force exerted, F of R will be F31 plus F32. F31 is minus 2.25 times 10 to the power minus 4 plus minus 8.44 times 10 to the power minus 5. If you put that together, you have minus 3.09 times 10 to the power minus 4, the vector I in Newton. And because of this negative sign, it is going in the negative x direction. So take note of that. So hello guys, let's go to 004. This is the last segment of your physics JUPEB exam, and that is modern physics. This is the part that is actually difficult for most students. They complain and all that, but I'll make it very simple for you. Just follow on as I teach. 7a, calculate the total binding energy per nucleon of an alpha particle. The mass of the neutron, proton, and alpha particles are respectively 1.008665 U, 1.007825 U, and 4.004603 U. So how do we do that? Write out our mass of neutron 1.008665 U, mass of proton 1.007825, mass of alpha particle 4.004603 U. The alpha particle is helium, that is helium 2,4. That is why you have 4 here. So how do we, before we calculate the binding energy per nucleon, first of all find the binding energy, which is Z of mass of proton plus N of mass of neutron minus X of alpha particle multiplied by your C square, or binding energy change in MC square. The change in M is your mass defect. So change in M, since it's an alpha particle, we have number of protons, number of neutrons. These are 2. Then if you add it up, it makes up your mass number. So 2 of these for the mass of proton as it is in the ball, plus 2 for the mass of neutron as it is in the ball. So if you multiply this and this, you have 4.0 minus the alpha mass of alpha particles. So multiply this and this plus this and this minus this gives you 0.028377 U. This is your binding energy. Then you multiply it with one atomic mass unit, which is 931.5 mega electron volt per coulomb square. If you multiply that with it. That gives you the total binding energy as 26.34 mega electron volt. Mega is 10 raised to power 6. So the binding energy per nucleon is binding energy over total nucleon. Binding energy is 26.34. Total nucleon is 4 from your alpha particle. If you divide it, you have 6.6 mega electron volts. So the next thing they say we should do now, we should define half-life. Half-life of a radioactive sample is the time taken for half of the element initially present in the element to decay. Or half-life of a radioactive sample is defined as the time in which the mass of sample left with one half of the original mass. So the last question says, which of the following radiation is alpha ray, beta ray, or gamma rays? A is saying are similar to X-rays. Y rays are similar to X-rays. That is, your gamma rays are similar to your X-rays. Are easily absorbed by matter. Obviously, you know X-rays are easily absorbed by matter. They travel with the greatest speed. Gamma ray travel with the greatest speed. The speed at which alpha ray will travel and beta ray will travel is less compared to that of gamma rays. They are similar in nature to cathode rays. When you talk about cathode rays, beta rays should come to your mind. So beta rays are similar to cathode rays. Thank you. Hello guys. Let's go to the last question of our PHY 004, which is still focused on modern physics. So I would like you to pay rapt and responsible attention as I wrap up with this last question. Because actually, you know, you'll be doing 8 questions. So 2 from each section. PHY 01, you have 2 questions. PHY 02, you have 2 questions. PHY 03, you have 2 questions. 04, you have 2 questions. So 8A, state 4 properties of X-rays. Very simple and straightforward. X-rays are electromagnetic waves with very short wavelengths. If you know an X-ray usually have short wavelengths and are not charged particles. X-rays are not charged particles. Number 2, X-rays cannot be deflected by electric and magnetic field. Very simple and straightforward. Number 3, X-rays can undergo reflection, refraction, polarization, diffraction, and even interference. So everything I've mentioned, they are properties of waves. Reflection, ability of ray to bend. Refraction, diffraction, ability of a ray to bend around obstacles in its path. Polarization, the interference when 2 waves of the same frequency, amplitude, and wavelength superimpose as they pass through a given point. So lastly, X-rays affect photographic plates. So those are the properties of X-rays. Uses of X-rays: 1, use it in photography. Very simple and straightforward. 2, use it in crystallography, that is the study of crystal lattice. 3, use it in radiography, that is when you want to treat cancers. For those of you that will be going to the medical field, people doing pharmacology, physiology, and physiotherapy, and even those in the medical sciences too, doing medicine, they also come across this. And use it in sterilization to protect food and fruits. So the B part says we should calculate the minimum wavelength of X-ray that can be produced by an electron accelerating by PD of 20 kV between the electrode. First thing you do is you write out your parameters. You have a potential difference of 20 kilovolts, which is 20 times 10 per 3 volts. You are looking for the minimum wavelength. You should know that EV equals to HC over lambda. So minimum wavelength is HC over EV. H is your Planck constant, which is 6.63 times 10 to the minus 34 joules. C is your speed of light, which is 3 times 10 to the power 8 meters per second squared. 1 electron volt is 1.609 times 10 to the minus 19. Then your V is only given as 20 times 10 to the power 8. So if you put that together, 6.63 times 10 to the power minus 34, 3 times 10 to the power 8, 1.609 times 10 to the power minus 19 times 20 times 10 to the power 3. If you put that together, you come here. I just gave you a rough sketch here, but you have it here. So if you put all that together, you get 6.22 times 10 to the power minus 11 meter. as your final answer. Write down the mathematical form of Bragg's law and explain each of the terms. When you talk about Bragg's law of diffraction, the mathematical expression is 2d sine theta equals to n lambda. 2d sine theta is equals to n lambda. Where your lambda is the wavelength of light, the wavelength of the diffracted light. Your d is the separation between the crystal layers. Theta is the angle of incidence ray, very correct. Then n is the integers, it can be 1, 2, 3 in the order of diffraction. The last question here, pay attention, we are wrapping up very soon. Determine the wavelength of the X-ray that was Bragg diffracted by cobalt crystals of interatomic spacing of 4.07 times 10⁻⁻10 if the first order scattering angle is 24. So they are giving us the first order scattering angle, which is 24. So what you have to do, theta is 24. Since it's the first order scattering angle, you divide it by 2. 24 divided by 2 to get the angle of it. So let me quickly do that for you here. So theta equals to 24 over 2, which is 12 degrees. And you know from your formula that lambda equals to 2d sine theta, or n lambda is equals to 2d sine theta. N here is 1, so n times 1 times lambda gives you lambda. So lambda is 2d sine theta. Your d is 4.07 times 10⁻⁻10 meter. So lambda is equals to 2 times 4.07 times 10⁻⁻10 times sine 12 degrees. So if you multiply all this, you get your answer, and your answer must be in meter. So if you multiply this, you'll be getting 1.69. Are you paying attention? Times 10⁻⁻10 meter. So this gives you your final answer. 2d sine theta equals to n lambda. N, where n is 1. So 1 times lambda still give you the same lambda. And fix all your value, your separating distance from your layers, and multiply it to your side. So if you get 1.69 times 10⁻⁻10. So we have come to the end of your physics revision for your JUPEB exam. So ensure you study all the topics and treat questions. And before you know it, you enter into the exam hall and you come out smiling because you have solved all the questions. Ensure you take note of all your formulas. Use the right formulas because it is the right formula that will give you the right answers. And I wish you the best of luck in your physics JUPEB exam coming up this Thursday. Bye.